Hello, I'm Sonali. Today I will be sharing a presentation on this membership restoring division algorithm. Experiment. We will study how division is carried out at the binary level inside digital systems. We will begin the theory, move on to the step-by-step procedure, and finally implement the algorithm using C programming in Turbo C. This experiment is important because it shows us how concepts like registers, shifting, subtraction, and restoration are applied in real CPU arithmetic. The objectives and outcomes of the experiment are to understand the restoring division algorithm, to implement it in C programming, and to verify the results with standard arithmetic. By the end of the experiment, you will be able to explain how the restoring division algorithm works, write and run a C program for it, clearly identify the quotient and remainder from binary division. The theory behind restoring division. The algorithm uses three registers. First one, Q register. This holds the dividend and gradually forms the quotient. M register. This permanently stores the divisor. E register or accumulator. This starts at 0 and stores the partial remainder after each step. Now I will be explaining the algorithm steps. The working steps are as follows. Initialization. We first set the accumulator to 0, load dividend into Q and divisor into M. Then we perform a combined left shift of the pair A and Q. Then we subtract M from A, and after subtraction, we check if A is negative. We store it by adding M back and set the quotient bit to 0. If A is non-negative, keep A as it is and set the quotient bit to 1. We repeat this process for the number of bits in the dividend. Final result. After all iterations, Q contains the quotient and A contains the remainder. This is called as restoring because whenever subtraction makes a E negative, we restore its value to a valid state. This algorithm essentially mimics hardware level division. For the algorithm flow in detail, the program is very simple. The procedure is very simple. We first start the program and enter the dividend and divisor. We then initialize the registers A, Q, and M, where A is taken as 0, Q as dividend, and M as divisor. We must ensure that all the registers are of appropriate bit length. Then we perform the restoring division steps. We shift A and Q to the left side. In short, the most significant bit of Q moves into the least significant bit of A. Then we perform subtraction, which is accumulator minus divisor. That means A is equal to A minus M. This is just a trial subtraction. We need to check if the accumulator is negative. We perform restoration. That is, we add M back to A and set the LSB of Q to 0. And if A is positive, the subtraction was successful and we set the least significant bit of Q to 1. After completing n iterations, where n is the number of bits in the dividend, the register Q will be the final quotient and the register A that is the accumulator will hold the final remainder. Here you can see the flowchart. It explains the problem or the procedure in short. Here we can see we first start the program, then n, which is number of bits in dividend, A accumulator is equal to 0, M is equal to 4 divisor, A is equal to 1 dividend. We then perform left shift A and Q, then A is equal to A minus M, then most significant bit of A is checked. If it is positive, the subtraction was successful, and if the uh, most significant bit of A is negative, we restore A. Then we perform this procedure n times, that is number of bits in the dividend, until the n is equal to 0. 0. The question is in register Q and the remainder is in register A. After that, we stop the process. Here you can also see the procedure is explained in much shorter way. Input dividend Q, divisor M, n is equal to number of bits. Output question Q, remainder A. Initialize A is equal to 0, Q is equal to dividend, M is equal to divisor. Repeat n times. Left shift A and Q by 1 bit. A is equal to A minus M. If A is less than 0, restore A is equal to A plus M. set question bit is equal to 0. Else A is greater than or equal to 0 or A is positive. Set question bit is equal to 1. After loop, Q is equal to question, A is equal to remainder. So let us walk through the C program for restore and division. I have written the code over here. To run this code or the program in the Turbo C application, we first need to copy the whole code. After copying, we can open the Turbo C++ application. Then we create a new file and save it as anything you would like to name the file. I'll be saving it as algorithm. Then close the Turbo C application. Then go to this PC, Windows C, Turbo C3. Then I'll find your file and edit it in Notepad. Then paste the copied program and save the file. After that, you can again open the Turbo C application. See, here we have already the code open, but you can also open it by this. By following these steps. We first include the stdio.h and punyo.h header files. Stdio.h, that is standard input output. Punyo.h are used for functions such as getch or clearscreen. I have written commands to explain each and every function. The print binary function is used to print a number in binary with fixed bit length. This command line is used to shift right and mask which one to get each bit. In the main function, we declare the variables a, q, and m, and we have taken n is equal to 4 since we only be repeating the process 4 times. Clear screen, as we know, it is used for clearing the screen. Then these 4 lines of codes are used to take the input from the user. Command of code is used to validate input values. Then q is equal to dividend, m is equal to divisor. So dividend is stored in q and the divisor is stored in m. These both are used to initialize registers. Then this line of code is used for to print the table header. Main part of the code. This line of codes are used to reference the A and Q pair. After that, P is equal to A minus M is used for trial subtraction. This line of code is used to print the current values of A and Q. And then if and else commands are used to check and restore if A is negative. A is negative, then we perform restoration, that is A is equal to A plus M, and then we print the output. And if A is positive, we perform the else command. And as for the final result, this line of codes are used. To run the program, we will be pressing the Ctrl and F9 key, which will open the output window. For example, we will be taking the dividend as 13 and the divisor as 3. And as we can see, the expected outcome or the result has been displayed, where question q is equal to 4 and the remainder a, which is equal to 1. Two more examples where the dividend is taken as 10 and 3 and the divisor as 3. The initialization has taken place. Then left check. Since the a is less than 0, we perform restoration. Again, in the second step, a is less than 0, then restoration has been taken. And then we get the answer. Final question q is equal to this, which is 3 in decimal. And final remainder a, which is this, which is 1 in decimal. For the next example, dividend is taken as 6, divisor is taken as 3. Again, the process has been repeated. Initialization, restoration. Here overview, we can see it here. Initialization, set A, Q, M, shift left, and subtract M from A, and then we take the decision. If A is negative, we perform restoration, and if A is positive, we continue the process. In conclusion, we have implemented the restoring division algorithm in C using Turbo C. The experiment shows how division is performed using registers, shifting, subtraction, and restoration, exactly how it happens inside computer hardware. This not only strengthens our understanding of binary arithmetic, but also bridges the gap between theory and practice. Thank you.